Hi, my name is Tomislav and I'm a software developer at StyriaAI. I work mostly on machine learning based services, data processing pipelines and integrations with clients. Today I will talk about data pipeline for AI and AWS services we use for that process. I will start by talking a little bit about who we are and what we do. Then I will tell you what do I actually mean when I write and tell categorization. Finally, I will define the problem we are trying to solve and offer you our solution. So let's start. Who are we? We are a small team, but we are rapidly growing. Currently there are 14 of us, and we are comprised mostly from data scientists and developers. We are a proud member of NVIDIA Inception program, and we are a part of Styria Media Group. How many of you have heard about Styria Media Group? Okay, not many. And how many of you have heard about Njuškalo, 24 sata, Večernji, Pixel, or Poslovni dnevnik? Most of you. So Styria Media Group is actually the owner of all of these brands, and Styria Media Group is the biggest media company in this region. And it has a reach of up to 90% of internet users in Croatia. It also has media companies in Slovenia and Austria. So the whole Styria Media Group generates a lot of data. And what do we do with that data? Well, we do mostly computer vision and NLP. Some of our projects include image similarity search, which is a solution awarded by NVIDIA. When I say image similarity search, that's basically some software that allows you to compare two images based on their content. And you can get the distance between two images, the similarity between them. Another example would be ad categorization, and I will talk about that during this presentation. And why do we do anything? Why does a media company need machine learning? When you're a media company, your competitors are internet giants like Facebook and Google. And they are really good at machine learning, and they are pushing it really hard. And once you have those services somewhere, clients begin to expect the same level of quality even from you. And so you must, if you don't want to fail, you must do machine learning. So categorization. Most of you have used some sort of classified service, for example, Njuškalo, and you're already familiar with the structure of the categories inside. Here is a simple example of the categories. Here you have electronics, inside you have computers and phones, and for example, inside a computers category you have laptops and PCs. This is quite a simple tree, category tree, and when I say category tree, this is what I mean, the whole structure of all of the categories. Njuškalo, for example, has over 1,000 categories, and things can become quite complex. So let's say you want to sell your Samsung Galaxy S9. First, you need to take a look at every level. So first level, vehicles, electronics, pets. It's probably electronics. Then you need to pick between computers and phones, probably phones. And since it's an Android phone, you pick an Android category. Obviously, that's a lot of steps, and it's pretty complicated. You can imagine doing that with 1,000 categories. Well, you don't have to imagine it, because we have an example. For example, you're trying to sell an ice machine, and this is what you get in a Njuškalo app. Well, after it starts. What is the category that best fits an ice machine? Where should that category be? In a kitchen? You don't really know. And the answer is, since this is not working, just a second. This is a GIF animation of what you see when you need to pick a category. Obviously, there are a lot of categories, and you don't know if there is a category for an ice machine. Maybe there's some category that gathers both ice machines and some other types of machines. If you want to sell your ice machine, you should look at bar equipment. So our solution to that problem is the next one. So you want to sell your headphones, for example. You take a picture of your headphones, you send it to us, and we return you a category. And this is what it looks like. Okay, so this is quite simpler than the first one. Now we're going to talk about the things you need to do to make something like that work. The first thing you need to have is some machine learning model that takes an image as an input and outputs a correct category. If you want to train such a model, you need a lot of data. And you need a lot of data in a form of input image, output category. Input image, output category. So we have that data, but the problem is that the data we have, the images, billions of images we have, and the category tree are on AWS. And we need to get that data on the premises because our training machines are on the premises. Why are we using on the premises training machine? Well, mostly for the cost reasons, because we are running a lot of experiments all of the time. So what do we actually need to do? We need to take all those images and pack them into a single TensorFlow record file. What is a TensorFlow record file? That's basically a file format optimized for usage with a TensorFlow library, and that's a library we use for training our models. Another thing we need to do is, if you want your model to work good, you shouldn't put garbage as an input. And so you have to take all of your photos and run some data augmentations. When I say data augmentations, what do I mean? Resizing, rotations, zooming, cropping. This is an example of a mirror fill, because as an input we want a square image, and not all images are square. So we fill the missing data by mirroring the data inside. Okay, so how do we do that? Well, this is where the data pipeline comes in. This is an overview of the whole data pipeline, and we are going to go through every component and explain it in a little bit more details. Before you can run your pipeline, you need to have the data. And as I mentioned before, our images are stored on the S3, and we have another Postgres database that stores our category tree. So all the information is about the categories, about the ads inside those categories, and all the images inside those ads. After we have the data, we can run our pipeline. The first step is exporting the categorization tree. And this is exactly what we do. We take all the categories and relations between them, effectively creating a tree. And for every category, we get a list of ads. For every ad, we get a list of image IDs. This is a step that lasts for about 20 minutes, and the category tree is the data we use in every step of the pipeline. So we decided to run these steps once and save the data to a file, and after that you can use that file and load it in a matter of seconds, and that's great. So now you have the category tree, you have all of the image IDs you need to use. Now you have to get the real data from the S3. And this is what the next component does. This is the component that gets all the data and runs all the data augmentations on them. There are some problems we need to solve in this step. The first is we have a lot of images, around 50 million images. We don't need to use all of the images for training, and more importantly, we don't need large images, because as an input to our models, we have a square image 256 times 256, and most of the images are larger than that. And if we were to download all of our images on the premises, we would generate a lot of traffic from S3, and that traffic isn't free. The solution to that problem is we run this step on an AWS instance. The next problem we have is, even after we filtered all the data we will use, run our augmentations, we are still working with around 30 million files, small files. And managing 30 million files on your local storage is hard, it's problematic. The way we solved this problem is we grouped our images per categories. So we took all of the images from a single category and put them in a single HDF5 file. HDF5 is a file format that allows us to put a bunch of images inside it and gives us random access to each and every one of them. This is something we need later. Okay, and our initial solution for this problem was to run a large AWS instance. That instance would download all the images from the S3, process all the data, generate HDF5 files, and upload those files on the S3. This solution worked, but it was slow, expensive, and it wasn't really scalable. What we decided to do was to use AWS Batch. How many of you have heard of the AWS Batch? 2, 3, 4. How many of you have used AWS Batch? 2. Okay, so AWS Batch. AWS Batch is an AWS service that allows you to define some job, some program you need to run, and put it on a job queue. And AWS Batch will automatically run workers that will handle those jobs. When I say workers in this sense, I mean basically AWS instances. And this allows you to, for example, if you send a single job, AWS Batch will run a single instance, execute that job, and then shut down the instance. If you run 20 jobs, AWS will run 20 instances, run all of the jobs at the same time, and after they're finished, it will shut down the instances. Obviously, there has to be an upper limit on how many instances you can run at the same time, but you can change that number. We are using 200. So if we, for example, send 1,000 jobs on the job queue, we are basically running 200 instances, and they are taking the jobs from the queue, and after they're finished and the job queue is empty, AWS Batch starts to shut down those instances that don't work anything anymore. This is great because if you have a single job that lasts for 10 hours, for example, and a bunch of jobs that last for 5 minutes, you have to run only a single instance for 10 hours. All the other instances will shut down as soon as they don't work anything more. So, how did we use that for our case? We run a separate job for each of our categories, and similarly to our previous solution, this job takes all the images from that category and downloads them from S3, and then it runs all the augmentations and writes all the data to a single HDF5 file. Finally, it uploads that file back to S3. So if we have 1,000 categories, we generate 1,000 jobs. After they all are finished, this step is done. By using AWS Batch, we reduce the time of this step from around 24 hours to 2.5, and we also reduced cost from $46 to $10 per run. Not finally, but the next step is, since we need our data on the premises and we are still working on the AWS, we need to download that data, and this is what this step does. After we have the data on our local storage, because I mentioned before that we need a single TF record file that contains all the data for efficient training. This is basically what the last step does. It just opens all of our HDF5 files, takes a file at random, takes an image from that file at random, writes it to a TensorFlow record file, and continues to do that until it takes all of the images. This way we have a single file containing every data we need. And this is basically the last thing we need to do in this step, because after we have the data scientists can actually train the model. To recap, by using AWS Batch, we reduce the execution time, reduce the cost, and improve scalability. So if you have any questions.
So you mentioned the job queue in the AWS batch. You are using it asynchronously. Can you use that synchronously so that the second job starts right after the first?
Yeah. Our case is pretty simple, but the AWS Batch service is quite complex and allows you to make job A dependent on the result of the job B, and quite a bit more complex structures. So yeah.
What did you use before AWS Batch?
Well, as I mentioned, we use just the server and just the AWS instance, a single one, but a large one, so we could process all the data and do our job.
And you said also the 24 hours.
Yeah.
Are there any alternatives to HDF5, or how come you?
Sure. You could use. There are some alternatives. We decided for HDF5 simply because it allows us random access of specific images. And if you want to train your model properly, you need to be careful that your data is random. So if you take your data and make it and order it in a different way, you can get worse results. So you need to be careful about that. And HDF5 simply allows us to do that. And
how big is one such file, this HDF5?
it depends on the category, but all the files together, for example, for Newscalo, can be around 300, 350 gigabytes.
And these are optimized already, or are they, like when you get to the HDF5, they're optimized for the learning phase, right? So
they are prepared in a way. They are squared images and all of that. But when we merge them, this is the step that we actually optimize the data for that library, for that specific library. So if there are no more questions, we are hiring, and not only data scientists, but also software engineers and DevOps engineers. And well, contact us if you want to work with amazing stuff. If you want to discuss this in a bit more technical details, you can ask me outside on the break, or even better, you can join us at our first StyriaAI Tech Talk next Thursday, so 25th October at Hub 385 in Zagreb, where we will discuss this in a lot more details and more. You can find more information at meetup.com. Thank you.